Hi, I'm Muhammad Karfauzi bin Muhammad Anwar, a student from S5T25 will present the subtopic 5.3 Protein Synthesis Translation. Let's check it out. Translation is a process by which the genetic code contained within a messenger RNA molecule is decoded to produce a specific sequence of amino acid. Translation occurs in the cytoplasm. Following transcription and, like transcription, translation also has three stages: initiation, elongation, and termination. Before we go to the stages of translation, we must know the activation of amino acid. Amino acid tRNA synthetases are enzymes that link amino acids to their corresponding tRNA molecules. The resulting complex is charged and is referred to as an amino acid tRNA. Present in the cytoplasm, it is an enzyme, amino acid tRNA synthetase. The enzyme macromolecule has two binding sites. One site recognizes the amino acids. This is followed by the binding of the ATP molecule and release of the pyrophosphate, resulting in activation of amino acid. Finally, the tRNA and the activated amino acid bind together. This marks the commencement of first stage of protein synthesis, the initiation stage. Now, we go to the stages of translation. During transcription, the genetic code DNA was turned into mRNA and modified. Now, the modified RNA is ready to be turned into a protein by translation. Translation consists of three stages: initiation, elongation, and termination. We check it out the first stage, which is initiation. There are four special codons, one that codes for start and three that code for stop. Translation begins with the messenger RNA strand binding to the small ribosomal subunit upstream of the start codon. Each amino acid is brought to the ribosome by a specific transfer RNA molecule. The type of amino acid is determined by the anticodon sequence of the transfer RNA molecule. Complementary base pairing occurs between the codon of the messenger RNA and the anticodon of the transfer RNA. After the initial transfer RNA molecule binds to the start codon, the large ribosomal subunit binds to form the translation complex, and initiation is complete. In the large ribosomal subunit, there are three distinct regions called the E, P, and A sites. The next stage is elongation. During elongation, individual amino acids are brought to the mRNA strand by a transfer RNA molecule through complementary base pairing of the codon and anticodons. Each anticodon of a transfer RNA molecule corresponds to a particular amino acid. A charged transfer RNA molecule binds to the A site, and a peptide bond forms between its amino acid and the one attached to the transfer RNA molecule at the P site. The complex slides down one codon to the right where the now uncharged transfer RNA molecule exists from the E site, and the A site is open to accept the next transfer RNA molecule. Elongation will continue until a stop codon is reached. And the last one stage is the termination. Termination happens when a release factor binds to a site at the stop codon and the polypeptide is released from the transfer RNA in the P site. The entire complex dissociates and can reassemble to begin the process again at initiation. The purpose of translation is to produce polypeptides quickly and accurately. After dissociation, the polypeptide may need to be modified before it is ready to function. And now we have reached the end of the video. Thank you for watching. I really appreciate that you took the time to be here and listen to my presentation, especially for my lecturer, my family, my fellow friends, and absolutely for myself. Thank you for helping me in making this video. See you soon and goodbye.